We were talking about transformations of quadratic functions, and we want to describe transformations of quadratic functions and write transformations of quadratic functions. So we'll start with our parent function, which is f of x equals x squared. And so we can graph that 0, 0, over 1, up 1, over 2, up 4, and over 3, up 9. And our y-axis, so we can use that as our line of symmetry. So over 1, so back 1. Over 2, back 2. Over 3, back 3. 1, 2, 3. So then we have our parent function there. So if we just focus on how we get our first couple points of our parabola as we head to the right away from the vertex. So for the parent function, if we're just going from the vertex, we're going to start by going to the right 1, and then we're going to go up 1. Then we go to the right 2, and then we're going to go up 4. And then we go to the right 3, and then we go up 9. So that's if once we find the vertex, with a scale factor of 1, because the a value or the coefficient in front of the x squared is 1, we go to the right 1, up 1, right 2, up 4, right 3, up 9. Well, now we have this new function, j of x, and j of x we will fill out in this area over here. But we want to pick out the points that are going to be easy to calculate and easy to graph. And so the first thing is we want to start with the vertex. And the vertex in this case is going to be located at 1, 4. Even though it looks like -1 here, remember this is backwards because the original function that we're given is y equals a times the quantity x minus h quantity squared plus k. So that negative sign throws everything off, because if we substitute in a positive 1, the negative sign stays. If we substitute in a -1, then it switches to positive. So that's why that one looks backwards. So our vertex for this parabola is going to be, for this parabola, j of x, is going to be 1, 4. So that's the vertex. One, 4. So I'm going to go over 1, up 4. 1, 2, 3, 4. Now, once we go to there, if we had an a value of 1, then we would do this from the vertex. We'd go over 1, up 1, over 2, up 4, and that would be our parabola. But our scale factor here is -3. So for j of x, we're still going to plan to go to the right 1, and to the right 2, and to the right 3. But now what we have to do is we have to scale what the y value does. So we take what happens to the y values, and we're going to scale them by -3 to get our new y values. So instead of going up 1, we're going to multiply by -3. So what that means is we're going to go down 3. And then instead of going up 4, we're going to go down 12. And then down 27. Now these are only in relation to the vertex. So from the vertex, now I'm going to go over 1, down 3. 1, 2, 3. And then I'm going to go over 2, down 12. Over 2, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I almost have my parabola completely drawn. The other way that we can get the other side is we can use our line of symmetry. And we can just count over. So 1, 2, 1, 2. 1, 1. And then I can fill out what the rest of my points are. So we have the point 2, 1. We have the point 0, 1. And we have the point -8, -1. And -8, +3. So the transformation for this one, if we're talking about how this parabola that we just drew, j of x, so there's a lot going on. We have a translation. And the translation went 1 to the right and up 4. We also had a reflection. And we also had a scale factor of 3. And the reflection came from the negative value in front of the 3.